Doors are closed.
Recording in
ready.
progress.
Okay, we're ready to start this session, the afternoon session, recycling technology advances. My job's pretty easy. I don't even have resumes to read, but we have a very distinguished panel, and they all think so. So we'll start with them. Our first speaker is Greg Wool. He's Vice President of Sales from EREMA North America, and he's going to talk on recycling technology for post-consumer plastic. If you need to know more about Greg, you can see his resume both online and in the program. Greg.
Thanks, Michael. And thanks everybody for hanging in late in the day. I will try to remain energetic and keep you engaged, but what I wanted to talk about a little bit was the technologies that EREMA brings to the table specific to reprocessing post-consumer content. Just by way of background, EREMA is a company that manufactures recycling systems, has been doing it for 35 years or so. The original designs were really focused almost exclusively on low bulk density products, specifically film. The company grew pretty strongly in in-house applications, post-industrial, real clean type stuff. But within the past 20 or 25 years, with the increased demand for post-consumer processing, the company has found ways to adapt to the specific requirements that that type of incoming material calls for. And so what I want to talk to today is some of those technologies that help process. First of all, I want to kind of identify what those challenges are when it comes to recycling and reprocessing, and how we can increase the value of the resulting recycled product. Because from my perspective, in order for recycling to really be successful, it has to be successful as a business, which means you've got two levers of pricing control. You can control the incoming material by keeping the cost down, or you can increase the value of the resulting recycled pellet. And it's the latter portion of that equation where EREMA can really can help the process, I think. And I just want to share some of those technologies with you and some of the unique challenges. So essentially, what we're talking about, and I apologize for this slide, I think I do a few things pretty well in this world, but marketing is not one of them. So this is just a few pictures I threw together to kind of tell a real basic story, where we're taking bales that folks in this room and at this conference are very familiar with. We're trying to convert it into pellets, which you see in the middle picture, which can then be converted into finished goods that people are repackaging products in. And if I were really clever, I would have put a third arrow in there connecting the dots and making it truly circular, because that's ultimately what happens. But as I said, I'm not a marketing guy. So where EREMA comes into play is right in this part of the circle, if you will. What comes out of our machines is what we like to think of as a very high quality pellet that can be sold to plastics converters, who are then going to make packaging or other durable goods to be resold into the marketplace. So let's talk about kind of where those plastics come from. You've heard this already today. I won't belabor the point, but plastics truly are produced on a global basis. This just provides some statistics showing, again, not a surprise, the majority of plastics are coming out of China, but Europe and North America are certainly significant players in producing plastic products. What does that mean for the recycling market? The recycling market itself is a robust market. That's a lot of the reason that many of us are here. And this is a projection that's going to show how it's going to grow over the next 10 to 15 years. And it breaks it down a little bit by type of polymer, which is interesting to us because we can process just about anything. I like to say if it melts, we can run it. But there are certain polymers that command more value than others. And so those are the ones that I like to keep our eye on. PET is well known, and that is something that is considered kind of separately within the world of EREMA. The ones that are of particular interest to us when it comes to post-consumer, although PET is by definition a post-consumer product, we kind of consider it separately, are a lot of the polyethylenes and polypropylenes. And so you can see that that's projected to grow quite significantly over the next 15 years as well. So that's obviously of interest to us. And if you look at, the pounds that are recovered, it kind of follows those same trends. There's a lot of PET, there's a lot of HDPE, a lot of non-bottle rigids, which is kind of an all-encompassing category. And there's still a significant amount of film in the post-consumer world. As I said, we process more film than anything else through our machines, or I should say our customers do. But majority of that does not come through the post-consumer channel. It's, like I said, post-industrial, in-house type of recovery. But of particular interest of the PET bottles, and of even more particular interest for the next few minutes that I'm going to be talking about, is the HDPE and the non-PET types of products. Again, if you look at all the plastics recovered over the last 10 years, what was interesting when I first saw this data was that there has been a slight decrease overall in plastics. And again, this data only goes to a couple of years ago, so I suspect it's bounced back a little bit. But the largest increase that you'll see there, even though the overall decline, is in non-bottle rigids. Again, post-consumer, HDPE, things along those lines. So it kind of supports the idea that we're looking at the right part of the market, I think. What was even more interesting to me is when you look at what these streams are in terms of composition, and even more so in terms of the markets that they're being deployed. And when I say composition, it's the same polymers we've been talking about. If you look at where the real growth is, it's polypropylene, it's HD, it's LD, it's LLDPE. So that's the material that's available to be reprocessed, recovered, and put back into the circular economy. If you look at the markets where these plastics are being used, the huge increase is in packaging, single-use plastics. It's sort of the black eye on our industry. It's where we get all the negative publicity in the general marketplace. But there's a reason that plastics is incredibly popular in packaging. Life cycle analysis shows that it's the lightest, most durable material you can use for packaging consumables. It helps in freight costs. There's tons of studies that'll show there's a reason that plastics are growing in that space. So the reality is we have to deal with it. And fortunately, we do have ways of dealing with it. We just have to be aware of the challenges in doing so. With EREMA's myopic view of where our business is, I just wanted to take a look at how it reflects on where EREMA has been for the past 6 or 7 years. And our business in the post-consumer space has quadrupled in the past 6 years, which further supports the fact that there's a great need for reprocessing post-consumer plastics. Just for perspective, the way we look at plastics recycling is we see 3 significant market segments that we track. Post-consumer is one of them. I mentioned PET. We consider that to be a separate business within our recycling world, simply because of the specific requirements of that. And then we look at in-house or post-industrial as sort of the third leg of our business. So by far, the biggest growth we're seeing across those 3 market segments is in the post-consumer space. And it's driven by forces that everybody here is well familiar with. We heard a lot about it this morning in terms of looking after the environmental impacts of not recycling, single-use plastics and post-consumer plastics. But the other driver that we see is all these brand owners saying, hey, we are going to put recycled content into our packaging. And they're going out to the markets and making these claims. Now, a lot of these claims are made by their marketing departments, so time will tell whether engineering can actually keep up with the pace of this, or if there's even enough raw material supply to keep up with these targets. But just the fact that they're going out to the marketplace and saying, we are committed to adding 30% post-consumer, or not even post-consumer, but 30% recycled content in our packaging in the next 10 years or in the next 15 years is a huge driver and a huge push for the rest of the industry to kind of get behind this. It builds momentum. So what are the challenges to processing post-consumer plastic? If we think about the pellets that we're producing when we're recycling post-consumer plastic, the converters who are making products out of them consider it a raw material. So think about your own business and incoming raw material to make whatever product you're making you've got some pretty high standards for what that needs to be. You've got some pretty narrow performance characteristics in terms of processors and plastic converters. They want it to be as close to virgin resin as possible. And when you think about the various different streams that post-consumer plastics are coming from, you can see the challenges in processing it to get it within those tight parameters. They want specified properties for viscosity, for weight density, for all kinds, for color. They want very low defect levels in their finished product, and a lot of that can be attributed back to the raw material they're putting in. Specifically, if you're talking about manufacturing film, stretch film, blown film from recycled incoming material, there's very little tolerance for defects or any kind of irregularities there. The other thing that a lot of people don't think about is the odor of recycled plastics. Maybe you've run into this. I know for a fact that you bring in post-consumer materials and you reprocess it into a pellet. Oftentimes the pellet is fine, but you go to make a product out of it, you're reheating it, and all of a sudden these odors bloom out again, and it creates problems. So I'll talk a little bit about some technologies to manage that as well. In a nutshell, people see this coming in to a recycling process, and they expect to see this coming out. So there's the fundamental challenge. So when we talk about what creates the challenge, someone had a better word for it, but I call them contaminants that are in the recycling, in the plastic stream that need to be dealt with. And why do they create problems when we're trying to create pellets that are near virgin quality? Well, those contaminants predominantly are cellulose-based. There's a lot of wood from pallets and shipping containers. There's paper, there's adhesives, there's glue. There's all sorts of things that when you put it through an extrusion process to make a new pellet, you're heating it up to temperatures well above their ignition points, and so you get burning, you get charring, and you get all kinds of even visual defects and irregularities that have to be dealt with, especially when you look at the relative melt temperatures of the polymers we're talking about. So one way to deal with that is to filter out these impurities through the extrusion and pelletizing process. The conventional way of doing this, and has been done for years and years, and EREMA actually offers systems that do it in this fashion, is you're introducing the recovered plastic at the front end of an extruder, cold from the outside, onto a screw that is heated. For those of you who understand polymers, which I suspect is a majority of you, the way that you're heating it up from a cold state to a warm state on a screw like this is you're introducing a lot of shear to the product, you're breaking down the polymer a little bit, and what happens is those particulates that you're trying to filter out end up getting smaller and smaller under these stresses in the feed section of the extruder. Conventional extruder, I apologize for the DEG, that's a European shorthand for degassing. It's a venting section in the screw. So the volatiles will come out midstream in the screw, and then you have a filter just before you pelletize it to actually filter out the hard particles from the polymer. So that's a pretty conventional extruder setup to deal with contaminants in a melt stream. The way EREMA approached it was, let's try to improve that a little bit. So what we do is we actually precondition the material before it hits the feed screw in a densifier that is tangential to the feed section of the intake portion of the screw. So we're bringing it up to temperature, not quite to melt temperature, 10 or 15 degrees below melt temperature. But what we're doing is we're driving off a lot of the moisture, we're homogenizing the material, and the idea here is we're completely focused on the quality of the pellet on the other end. So how do we reduce the stress in the polymer during the whole process? And one way to do that is to heat it up a little bit more slowly. And so we do a lot of that in this preconditioning unit before it's introduced to the screw. So what that looks like, if we go back to our model of a typical extruder, which, oops, now I've done it. How do I go backwards? There we go. The conventional extruder is modeled here. The way that we do it is we're warming it up in the preconditioning unit prior to extrusion. That keeps the contaminants of a larger size because the polymer isn't being sheared and isn't dramatically being affected. So we can filter it more effectively. filter out the physical contaminants. And then we have the vent section after the filter. Because what we found is that even through the filtration process, again, you're raising the temperature through shear, and you're actually creating VOCs in the melt stream. So it's much better to allow those to vent out of the extruder after the filtration and before pelletizing. You end up with a more consistent, less gassy pellet. I apologize for the technical term, but it's a gassy pellet. And what that looks like in terms of a schematic of the extrusion system is pictured here. Again, preconditioning into the extruder, being as gentle as possible through the filter, then the vent, and then the pelletizing downstream. The filter itself offers some unique advantages over conventional backflush or screen filters, in that we can remove a lot more contaminants than a conventional screen filter, up to 5% in the melt stream. It's continuously self-cleaning. I could spend an hour or so on just the filter technology, but just to give you some idea that if you look at the mechanics behind filtering out some of the hard particles in a melt stream, there are certain ways to do it that are better suited to a highly contaminated polymer, such as a post-consumer source, rather than a cleaner in-house source. Happy to go through this at greater length offline if anyone is interested. We also, for those applications that require very fine filtration, we can actually put a second filter at the end of the extrusion line before the pelletizing as well, so we can reduce the contaminant size down to 50 micron or so, which again is pretty important when you're doing very thin films and things of that nature. The venting I talked about is important because you are releasing, or you're creating a lot of VOCs in the melt stream, so you want to have plenty of opportunities to get that out, again, for consistency and quality of the pellets that will be reprocessed eventually from these lines. It also becomes important when we talk about, you might remember I talked about odor that's created from a lot of these post-consumer melt streams. And a lot of the odor is, there's two ways that odor is introduced into the polymers that we're reprocessing into pellets. One of them is from the products that are in the packages that we're recycling. You know, if you're recycling HDPE blown bottles that have detergent in them, or soaps, or any sort of chemicals with an odor, that odor migrates into the polymer. And so no matter what you do on a wash line or a sorting, before you extrude it and pelletize it, it's still sort of inherent to the polymer. So you need to find a way to get that out. And it also comes in not necessarily from the product, but obviously these are not coming from the cleanest of sources, and so you can also get odors from the outside as well. And you're dealing with a couple of different levels of volatility, if you will. You've got high volatile, low molecular weight substances. You've got low volatile, high molecular weight substances. Some of them are closer to the surface than the other. So a couple slides back, I showed you on our extruder line how we've got different locations for venting to get rid of some of these VOCs. But the stuff that's really deep in the polymers will often require a lot of post-pelletizing conditioning to really drive those odors out. And so what we offer in what we've developed is sort of a post-pelletizing step that will drive out some of those low volatility odors that are kind of deeper in the polymer. It's what we call refresher technology. Driving out VOCs is essentially a function of time and temperature. So what this allows is for the pellets to sit at an elevated temperature for an extended period of time, so you can really get into the, get below the surface and drive out some of those VOCs that are creating the odor, particularly in a post-pelletizing state. It's also energy saving because you can do this refreshing technology, this conditioning of a pellet with virtually anything. But what we're offering is, by doing it in line, you're taking pellets that are already at an elevated temperature, so you're reducing the energy, because when you talk about the processing cost of repelletizing, you want to keep that as low as possible. So it just provides some energy savings as well. So what you end up with is high-quality pellets that have been vented so you don't have a lot of gas in them, so they process quite well. And you've driven out majority of the VOCs that are going to create odor for the folks who are buying these pellets on the market. And if you don't take these steps, when they go to blow mold a bottle, or when they go to extrude a stretch film, or create an injection molded part, when they reheat it, all of a sudden they're going to see the odors on their end, and it'll all go back to their supplier, and it creates issues in the supply chain. The other thing that this process allows is sort of what I see as the holy grail of capturing or creating value in the recycled pellets. This whole process has actually been through the FDA L&O process for food contact approval. So our technology enables processors to actually use recycled content in food grade packaging, which is, again, adds to the value of the pellets that we're providing to the marketplace. And it's funny, the validation for a lot of this odor removal is literally we'll run lab scale tests, and we'll provide pellets to our customers, because we don't know what's acceptable and what's not acceptable for odor levels, and we'll provide them samples at various residence time, and you know, it's literally a sniff test, you know, to say, okay, that's okay, but that's not, which is great because the customer's happy. But some folks smarter than me thought, geez, wouldn't it be nice if we could validate it with science? And so what this is we put the pellets through a mass spec, and we can actually see the VOCs, you know, the levels of untreated. You can see the spikes of the various odor-causing chemicals get reduced going through the extrusion process, and then get virtually eliminated by going through the refresher process. So it's always nice when real-world experience is validated by science. Yay, science. So the idea is we're trying to add value to the recycled pellet that's available in the marketplace. It allows the processors of post-consumer plastics to be more profitable, therefore making everybody happy and hopefully recycling more product. Again, the idea being, let's contribute to the circular economy as much as we can. Hopefully that was helpful. I'm available for questions anytime.
Thank you, Greg. That was a really good presentation. Just by way of analogy, all of recycling is purifying. And right now, in this time of change, when people are going to recycled content, you're going to hear a lot more about yield, right? Yield's really important because the inbound bales don't equal the outbound product that can actually be used in consumer applications, especially when it comes to food. So I thought you did a really good job of explaining that, and I thought that was a very good presentation. Thank you. The second presentation, I guess 10 years ago, there wasn't a robot to be seen in any MRF, right? I think you'll have your own numbers, but I think for the whole segment, there's literally thousands now. You know, just in North America, just approaching that number now, at least in the planning stages or installed. And it's amazing because it's that kind of technology, smart technologies, are taking over a lot of facets of the supply chain. So our speaker from AMP is going to talk about overcoming barriers to recycling modernization with AI and data. And it's going to be given by Scott Chase. He's a former Citadel star football player. And he's their business development manager. Scott?
So everything he said was true except the Citadel part. I did not go to the Citadel. But very excited to be here. Appreciate your time. So let's talk about AMP and reimagining recycling through AI. Some of the material challenges that we see in recycling are cost of sortation, right? The high cost of sortation, capacity limitations. Something that's not up here is actionable data on how can you change your process in real time. Persistent material contamination from inbound low feedstocks, and chronic labor shortages, and just turnover in the industry in general. So that's some of what we're going to talk about, how our technologies can help improve the industry. The mission of AMP, when Matanya Horowitz started the company, was to reclaim more recyclables out of the waste stream before it got to the landfill. So he saw the stuff that was coming out of the MRFs and said, hey, that's a problem. How do we fix that? That's how AMP got started. At a glance, AMP was started in 2014 by Matanya. We've grown from 4 employees to over 250. A lot of that growth has been in the last 18 months. We have a full production system in Colorado. We've got 3 facilities, a lab, an office, and a full production facility. We have installs in over 25 states in the US. We're also in Canada and Asia. And we're retrofitting other facilities and testing new technologies as we continue to grow. We also have been given money by a lot of high-tech firms that invested in people like SpaceX and other high-end stuff. So we're thought of as kind of industry leaders, and we're going to continue to try and be that. Currently today, we have over 200 robots out in installations. Over 10 billion images a year are seen by our neural network, and every one of our robots is continually learning from that. So every time we put out a new robot, a new system, that system's data goes into our brain, our neural network. It's anonymized, and it allows all the other robots to continue to learn. Based on a study that was done by ISRI and the volumes of materials that we pulled out in 2020, we estimate that just from our robots alone, we've reduced 160,000 metric tons of greenhouse gases. So we're pretty happy that that's been pulled out of the recycling stream. AMP's technology really is 3 pieces. It's a lot more than 3, but it's the neuron or the brain, it's the Cortex robot, and it's our vision and clarity systems. And we'll talk about how they all work together to allow us to see a product, identify that product with high confidence, pull it off the belt and put it in the right bunker so that it can be recycled properly. You know, real simplification of it, right? The vision system is our eyes. And when we talk about how our AI works, our AI looks at an object just the way our eyes do, and we train it to do that. So it has to just see repetitive images, and it learns and learns and learns. Those eyes give the data to the brain. It's stored, it's repeated, and it learns from that. And then the brain tells the arms what to do. We also have another system where all that data is stored. When I said actionable data, we will talk about that. But that data is kept for our installs so that they can learn more about what their throughput is, what they're seeing, what they're missing, and how we can help them improve. This is our robotic sorting system. If you look at it, you have the CPU, the vision system, CPU, vision system, and the robot cage. This is upstream, so everything goes underneath the vision system. Data is captured, tells the robot what to do. That material that's being picked today could be changed within an hour if the MRF realizes, hey, our production of product A, commodity A went up or went down, and we need to focus on another commodity so that we get the value. They can change it right. Back. Come on. They can change it right there. Soon they'll be able to change it on their laptop in their office without having to go out to the plant. But right now, these robots are picking 80 to 120 picks per minute on belts that are going up to 250, 300 feet per minute. We've got 99% accuracy on several of our labels. We have over 120 labels. A PET bottle is a label. Blue PET bottle is a sub-label. Newspaper is a label. Cardboard is a label. So when we say labels, we're kind of talking about commodities, but that's how we talk about them in our network. And then payback for our systems, depending on your throughput in tons per hour, the number of shifts you run, could be as little as 12 to 24 months. So very cost effective. AMP clarity. I want to spend a little time on this, right? We talk about data. When you've got material running through your MRF, you don't really know what's going on until it comes out on the back end. You do a bale audit of your finished product or of your residue to see how things are processing. Our vision systems not only identify the product that we're telling the robot to pick, whether it's a positive sort or a negative sort, they do an entire composition of what's on the belt. So anything that's a label in our system, it's identifying as it goes under that vision system. We have the technology in our robots to say, did we make a pick attempt on the item we were supposed to? Did we make a successful pick attempt? And did we get it in the bunker? With that data, everything else went through. So now the MRF knows what's downstream of where our robot was. With that data, I actually am getting ready to finalize a sale to a customer because we were able to say, hey, we're getting all of your colored and natural, but there's 10% PET. And by the way, if we change the priority from natural to colored, we get more with the second robot. So we can actually tweak where the robots go and how they pick based on our data that tells them what's on that belt. This is the vision system. And this is really, it's not the brains, but it tells the brains what to do. Like I said, it's real-time capture of material for recovery data. It identifies material based on form, factor, and color. We're not using NAR or hyperspectral technology, it's purely vision. We have the potential to validate outgoing bales for purity, and we can also validate incoming bale quality at plastics processors, for example. We could put this, depending on the width of the belt, we can actually put this on an accelerator belt before their optical sorters, so they can know before they start sorting what was coming in. So that will allow them to go back to their suppliers because they know what bales are running, what shifts per day. They now have data to say, hey, we're getting too much contamination from this truckload, these bales. So it's really going to help them educate, clean up their material and process. This is a video of one of our installations here. It's single stream recyclers in Sarasota, Florida. They've got robots on fiber lines, container lines, quality control lines, and residue lines. They've got our single Cortex units and our tandem units, which is one of those, has two arms and can do, like I said, a negative sort or positive sort. Those tandem lines on fiber typically are set as a negative sort. They want everything taken off the belt but the fiber they want. But once we dial in our mass, which we'll talk about our mass estimates, that will be able to allow them to certify their bales for purity and for meeting its respects. We've got some work to do to get there, but that's our goal. We're continuing to innovate to make the data more important. Right now, if you see our clarity data, you're going to see 100 items were identified. We attempted on 80 of them, and we got 90 of them, right? That doesn't tell anybody who runs a MRF anything, because most MRFs operate on tons per hour throughput. So we're in the process of doing mass estimates and validating that information so that we can talk in the language of MRFs and PERFs so that the data is more relevant to what they do on a daily basis. This is a video of one of our plastic reclaimers. There's actually sound, so I'll shut
up. Robots and humans can work together in two different ways here. Firstly, a human at their best can pick maybe 40 bottles a minute. The robots are capable of picking up to 120 bottles per minute, all the time, day or night. So a robot is capable of learning and categorizing what it needs to pick those bottles the right way, allowing the humans to make some higher level decisions, allowing the robots to be the consistent tool we need. It's a nice piece of harmony between the both of them.
So with Evergreen, they're one of the nation's largest plastic reclaimers. We've helped them improve their bale purity, and throughput by over 200%. They also have made some recent purchases with other facilities, and they've already committed to put in another 15 robots in those facilities to continue to do the same types of things. The next is a video. If you look up there, you see the Pringles can. If any of you sat in the previous session, we partnered with Sunoco Packaging when they were trying to work on their sustainability goals and create a label, as we call it, that could be recycled in their MRFs and or other MRFs around the country. So we partnered with them, the Pringles cans, the Morton salt cans, all of those style cans, so that now they show up in their MRFs and they can actually help recycle products that they're making, right? Kind of back to that extended producer responsibility that Michael Pratt had mentioned. We've also worked with Keurig Dr. Pepper. They've asked us to help them identify K-cups in the waste stream and pull those out. We've worked with Starbucks to pull out coffee cups as people, again, are looking to get their ESG score up and have to start managing the EPR that's coming. They're coming to folks like us to say, hey, how do we identify our products in the waste stream? How can we quantify what we're selling, what's being recycled and what's not, to help find out where money needs to be spent for education or whether or not packaging needs to be changed to make it recyclable. The other thing that's really interesting about this slide, I love this, all these different colors. That was when we started back in 2014. Matanya and the first 5 or 6 employees of AMP, they would draw these images based off the pictures, based on the color. So green is always fiber, reds are plastics, but each one of those colors identifies one of our labels or a sub-label. And that was all done initially by hand. So when our robots are looking, that's what you'll see if you were standing at the monitor right next to the robot. You can see whether or not it's identifying stuff. We're continuing to innovate. One of the last sessions talked about plastic film. I've spent 13 years almost working in MRFs with Casella up in the Northeast. Every time I was giving a tour of our MRFs, our GMs, our plant managers, when I'd ask them to tell the group what their biggest problem is, 99% of the time, plastic film, plastic film, plastic film, right? We all know, I'd hate to be a maintenance person in a MRF. I can't tell you what the product is. It is in development. We hope that it'll be a solution that will allow for that to be less of a problem. But we're continuing to innovate. We're not just a robot company. We're not just an AI company. We're not just a data company. We want to continue to innovate and continue to provide solutions generally based with our AI. And we're looking at other technologies to enhance our AI where AI might not be able to get it done. But right now we haven't hit that as a big issue. And I believe that is it. I will be here with the rest of the panel, but I thank you for your time. And I was done.
Thank you very much, Scott. Our last speaker is Will Sagar, and he's going to talk about glass recycling and processing glass and improvements thereof. So, Will.
I'm glad to have the last slide before you get your beverage. And to talk about innovations in glass and technical advances in glass recycling, because that's a struggle these days. There's a lot going on. SERDC has worked very closely with Glass Recycling Coalition over the last several years to see what we can do to improve this. Just so you know who that we are not SERC. SERC is the Southeast Recycling Conference that you know, you're here. We have worked closely with SERC from our origin 15 years ago, but we are independent from them. These are the sponsors that make our work possible. Our mission is to unite government and industry to promote sustainable recycling. We really are looking to get more material into the value chain so that it can be recovered and used by the very strong recycling industry that exists in the Southeast United States. We work closely with government because government is an integral part of our supply chain in getting materials to market. The glass industry has made some aggressive goals for material recovery, just as we have seen from many of the brands that are using a lot of plastic packaging. We're seeing some in steel and aluminum as well. But the glass industry aims by the end of this decade to have 50% recycled material, post-consumer recycled material, in all of their products. Right now they're working along about a 31% recycled content in their bottles and jars that are coming to market. The infrastructure or the source of that material is going to make it hard because they are getting, as you can see, most of the material is coming from the Northeast and from the West Coast. Not coincidentally, this is where all of our bottle bill states, Iowa comes up in this as well, because it is where we have container deposit legislation that drives a lot of the glass recycling to get back into the system. And part of that is most of that tends not to be going through our single stream systems. The glass manufacturing in this region is very strong. We've got 6,000 people working in either the beneficiation or the creation of new bottles in plants. And as we look at where these facilities are located, it kind of jumps out to me that they really run along the I-85 corridor, with the exception of a half a dozen that are out in other places. But for some reason, Interstate 85 seems to be the home of a lot of glass work. Looking more broadly at the full glass infrastructure, the Glass Recycling Coalition, GRC, has put together their identification of not only the manufacturers, but processors, what's going into fiberglass instead of just into containers, and where the certified MRFs are, and I'll speak just a little bit more to that. But as again, you can see that this infrastructure is located where most of our population has found itself, and again is very, very strong in the Northeast. The Glass Recycling Coalition actually uses this, but I think it might have been a Glass Packaging Institute that started this. And did you guys build that?
What?
This chart?
Yes.
Yes, I think, and I'll credit the chart to RRS, who is also involved in a lot of this work with the Glass Recycling Coalition. But just look at what materials start, how much of it's going straight to landfill, and this is, for our industry, I think, an embarrassing number, that just a lot of it's never even getting a chance to be recovered. We do have a good portion that does go to the MRFs. It goes through some process, but a large part of that winds up going to landfill as landfill cover, and some of it as landfill waste coming out, particularly because it got sorted into places that it shouldn't have been. And we see some of it going into mineral replacement. This is our carpet industry, particularly in your neighboring state, Georgia, drives an awful lot of the PET recycling in this country, and is also consuming a lot of the glass. This glass is ground to very fine, and it's going into the backing of many of our carpets, and it is a large part of what happens to our facilities. But you can see we've got some going into durable goods and others, and we're down to about 13% that's going into glass containers for packaging for consumer products. There's a lot of obstacles out here for glass recycling. I'm not going to read all of these slides, on this slide to you, and it is very busy. But largely what we've got is, in driving most of this, is the economics are not working in glass recycling. It is, when making new bottles, it's hard to use recycled content in large quantities because it's just not getting there clean enough, and we don't have enough money flowing back up the stream to make that work. Now, with the GRC, We are doing a lot of work along those lines in the GRF. Part of that, and working with GPI, SERDC did some work early, or summer before last, and we surveyed the MRFs in the SERDC region, which is the 11 states that were in that one slide. We surveyed 90 MRFs, and we had a 91% response rate, just to see how well they're recycling glass and making the capture there. It was interesting, 15% of our MRFs in the region have not yet become single stream MRFs. We've still got some source separated MRFs out there. Capacities varied quite a bit, from 800 tons a year to 500,000 tons a year. So we've got some very large facilities, but most of those facilities in this region are falling between 20 and 40,000 tons per year. So there's some modest MRFs around. We've got them mapped as well. We don't have that slide with us today. MRF's biggest struggle isn't glass, it's just dealing with contamination in general. Number one at the top is there's too much film going into our MRFs, and that's just where their primary focus is going to be, to get rid of film and right back to tanglers, which they're managing the same way they manage film. There's trash going into it, and it was interesting that some of the MRFs identified glass as a contaminant coming in their stream, because they've said they didn't want it and are considering it that. Another interesting fact we picked up in that is about 10% of our MRFs are operating beyond their design capacity. And if we think about that, that has a very detrimental effect on what our MRF quality is going to be coming out of that. By and large, we've got about 10% excess capacity, design capacity in our MRFs, because most of them are not working over that. Most are managing glass just with a glass breaker, which is getting the glass out of the system and separating it. A few have got some air currents and trommel screens and some other equipment to make it somewhat cleaner, but that equipment is not universal across our system. We also found out where our glass was going, and only about a third of it is really headed back to beneficiation, so that it can then go on to being consumed as into the corporation into new bottles. So to address that, we are back then again working with the Glass Coalition to see what we can do to step up what's happening at MRFs, and looking at how busy they are. We've got to recognize a lot of what they've got is in good quality, and many of the others not in such good quality. You can look in the bunker on the right, that's a lot of bottles. In the bunker on the left, that's a lot of bottles, but they're not all glass. There's steel in there, there's plastic in there, and that's certainly making it a lot harder for them to do what they do. So about 2.5 years ago, the MRF certification program was launched by the Glass Recycling Coalition to see what we can do to encourage MRFs to move up or step up their game and better recover this material. So we want to ultimately see a growth in the quality. Hopefully by having this certification, some of the MRFs will be in stronger negotiating positions with their local governments. We want to get best management practices deployed, and how we can use that as a tool to get them there. The certification looks at what type of sortation is in place. It looks at where the source of the material coming in. We've got a lot of glass drop-off systems that may work parallel with single stream curbside that doesn't have glass, and we're getting better material out of those. And then how many pieces of equipment do they have to do that? And ultimately, what does the material look like? If I can back up to the previous slide. If I'm backing up or going forward. But as we look at what is the glass product that's in the bunker that's going to be loaded on the truck to leave the MRF, we can have some that's very clean, as we see in the center. If we look then to the left, you know, we've got all kinds of stuff. in that's going to be headed to the beneficiation to have to be managed. So this is how we want to get to glass that looks like this in this slide coming out of these facilities. And to date, we have, with taking these qualities, put them to these MRFs, and that have met the gold and silver standards. There is a very objective point system for the materials that they have, looking at the percentage of contamination that's in their material, what equipment they've got to get it there, and ultimately where does that material go afterwards. Obviously, if it's going back into beneficiation so that it can be used in either fiberglass insulation or in bottle-to-bottle uses, that's going to score higher than it does if it's going to some other aggregate usage. And obviously, if it's going to be used as daily cover in landfills, that's falling on the lower end of our spectrum. So that's where we are encouraging that deployment of better equipment that's out there. We've got some vendors here that have some of that equipment. Some of those are SERDC sponsors, but that's where we are with glass and looking to help them move forward with what they do, and we look forward to our questions. Thank you.
Thank you very much, Will, and thank you to the panel. I'll ask first, does anybody have questions out there for the panel? If you don't, I have some. So, anybody?
Yeah, you get some.
Okay, back there. Go ahead.
Mike, he's got the mic over here. Michael, look here.
Okay, to Dave. Go ahead, Dave.
Can I go first?
Sure.
Thank you. So great discussion. I grew up in New York, and in New York we had a bottle bill. So you would be hard-pressed to find any bottles littered, at least on my street in my neighborhood. I'm just curious if anybody had an opinion on if that bottle bill is the right way to go. I know some people love it, some people hate it. And I was just curious if Will, if you had any opinions on a bottle bill.
If your goal is to collect more of the materials that the deposits are on, the bottle bills work.
I concur.
You have some bottle bill structures that work better than others, and we would feel that if you are going to have a bottle bill, you do really need to go look at what's going to, how you're going to control the overhead of the program, but very importantly, what are you going to do with the unredeemed deposits, because not all bottles are going to come back. And many of the legislatures that in states that have them use that to rob the fund to go support the general fund in general, or the general fund and their other expenditures, and it would be our position that that money needs to be reinvested back in the capture of those materials.
If you're interested in more information about that, NWRA just released a study that we participated in, and it's available if you go to the NWRA website, or you just type that in on deposits, and it compares the various systems for the amount of revenue change there would be in existing recycling programs. So it'd be worth looking at.
And traditionally, many of our beverage manufacturers have been very strongly opposed to bottle bills. I see that softening because they've set some very ambitious goals for their packaging in this decade, and there is quite a bit of softening on that resistance. So I think politically this may be in a better place, and you have got an effort in Congress for a national container deposit bill that may or may not have legs.
So we have another question over here, if you want to raise your hand.
Just a quick question. I'd love to hear or read more about the initiative with glass recycling. Is there a report or a website that we could go to learn more?
What's the question?
she wanted to hear more about Glass Recycling Coalition and Glass Recycling Foundation.
Is there an initiative or a report or a website that we could go to?
There is glassrecycling.org,
That's
I
awesome.
think.
Okay.
If not, my information flashed there, but I can get you a card and make sure you have it. There is quite a bit of information there. There is a lot more information on the backside of it for their members. But if you're seeking more, I'm sure many of those members are happy to share some of that information that's back there, because we are all working towards that goal of getting this out. And really the MRF certification part of that is only one step they're taking. There's work going on that the GRC is making grants, and this program is in its infancy, but there's been a significant program in Ohio and another in North Carolina that have shown some very good metrics early on. The North Carolina one was first, and that one's, I guess, 18 months into operation now. But they've done quite well, and that was a Central County setting up a hub and spoke to collect material from multiple sources that were drop-off and restaurant collection, and take that then to the beneficiation plant down the road. The Ohio facility was to purchase some equipment for just some freestanding collection points around, and that program really just got rolling earlier this year, I think, or maybe it was last fall. But they have shown some initial good response, and the work there has been supported further by then the creation of the glass, in addition to the Glass Recycling Coalition, the Glass Recycling Foundation, which is a tax-exempt organization with 501c3 status, and it's been a lot easier for them to raise larger amounts of money, and there's been grants that they have been able to fund either through the GRC or directly from GRF, depending on the project. And I know they've had some work on the ground that's in place in Chicago already as well. But all of that is there, and it's linked off of our website as well. But it's like, I'm pretty sure it's glassrecycles.org.
I think we had a third. Keena, did you have a question?
So this is going to go to Greg. You talked about the different manufacturers. I know, oops, sorry. Thanks. Hey, how are you? I know that you've talked about the different companies, and it's funny that John Mitchell just brought this to me with Coca-Cola Beverage Florida. They all have this every bottle back program that's going on. How are you seeing that work so far? Are you seeing that they're getting enough materials back to live up to the content levels that they need?
The conversation that we have repeatedly with people who want to increase recycled content in their finished product is a question that comes up in the course of the project as the project evolves is, have you secured supply? Because without that, the project kind of falls on its face. So the race right now is, in fact, to secure supply to meet some of these ambitious goals that Coca-Cola has and other brand owners. And I expect that is going to go right back to the MRFs, because the MRFs control the supply. So I think the race is on to secure that, for sure.
Yeah, I have something to say about that. I have about supply. You know, all the plastic except 7 and polyvinyl chloride 3 is getting recycled out of the MRFs today, all of it. And even in some of the manufacturers, they're able to get rid of some of the 7s for other uses, some tertiary uses, some secondary uses in the 3 through 7 bales. So anybody else getting into the industry is going to have to compete for the MRF supply. And because it's tight, all of that material is going for positive value. So the chances of them coming in has to be done on a cash basis. They have to go out and purchase that material. So it's really interesting, tight supply right now.
You've got chemical recycling coming in to impact that a lot too. Now, I don't think that the chemical recycler can create resin pellets for the same cost that the mechanical recycler can. I don't have any background or understanding well enough what they do, but it seems to me that that's going to be part of it. But they are there. But I think in addition to the lack of supply coming out of the MRFs, we don't have the infrastructure in place to process enough to meet the goals of 2030 yet either. So there's a lot of work to do.
May I ask another one?
Yeah, go ahead.
So for Will, I'm not ready to drink wine out of a box yet. So how can we get more glass recyclers here in the state of Florida?
Deposits work. That's not a SERDC position to advocate for them at this point, but we do know they work, and we'll tell you that. And the national bottle bill would certainly impact that. There's a lot of glass to be collected here. Florida typically has got good legislative support for private industry. This doesn't exist in others. So it's, how do we marry that and get that together? I think we need to probably convene some glass interested folks along with others here, and that's only about a month away. GRC is meeting here, I think it's next month.
Next month,
Yeah.
Sarasota. Yep.
And I understand on that agenda, there is going to be some focus on bringing in some of the participants that could affect change in Florida. I don't know the full agenda for that meeting yet.
Keen, I think right behind you, we had a question from this man here.
This mixing up, can we collect the glass separately? Like we collect the cardboard only, glass only. Why we had to mix at the source, and why to struggle to separate and all this industry? I'm in recycling industry. The separation of the glass is a big problem. It is mixed with paper. If you send that paper bale to the paper mill with the glass contamination, that entire bale will be rejected. All our efforts of separating, baling, selling is go down to the drain. Why can't we separate at source in home? Instead of collecting bins 8 times, we bin separately for glass. So we can avoid the problem. In Japan, they separate that. Even in restaurant, they have separate 3 bins: paper, water, list. Why can't we do in this country also?
And they do that in Oregon too. They have separate glass collection.
Prevention is better than cure. We should
Decatur,
prevent.
Georgia surveyed their population and said, will you pay $1 or $2 extra a month for separate glass collection? I don't know that they did it in an objective vote, but they allowed them a way to go online and cast their interest, and they did receive affirmation from the households that they would pay that. And Decatur put that in, that's probably 3 years ago. And there's a separate glass collection there, and they raised the fee to do it, and there's been no pushback to the local officials about it. So but that third collection is there's a cost, and it's got to come from somewhere.
Not cost, sir. For example, I am coming from Wineland. We collect in my city 4 times, 2 bins per week. One is mixed waste, residential waste, kitchen waste. Other bin mixed with paper, plastic, glass, metal, and all these things. Instead of that, once in a month, glass, just a pure glass. And also in my town, they increased the $2 per month. No, $4 per month. But service is the same.
So
No, but
there's relative costs involved.
No, we need to work prevention, not finding the cure. No, it is a waste of money. Whether you pay or pay, somebody is paying it. Indirectly, it is going to the taxpayers. And one more thing, it is one of the biggest problem, separation of the glass in recycling industry when it comes mixed with glass. We can separate plastic, we can separate metal, we can separate aluminum. We cannot separate glass. It is a health hazard. People will get injured. It costs money. If that person goes to the hospital under workman's compensation, insurance goes up. And in recycling industry, we have 4 categories: clerical, and the people are working in the plant, operating machine operator, and the people are cutting the metal. We have, in cutting the metal, 10% workman compensation in recycling industry, 10% of the salary. It is a big penalty for the people because we can separate at source. We need to put dollar makes sense. You increase the tax, increase the person who is not who are not separating it.
Yeah, I think everybody would agree with you that separating at the source gives you the purest commodity and doesn't allow for cross-contamination. But the highest cost there is in the recycling system is the collection cost. And what Single Stream did was, when it initially came out, it dropped the cost of recycling in half from what it was previous. Now, does it cross-contaminate? Yes. Is that a problem? It's a big problem. If you can afford to have a third collection, that would be something that you'd want to consider if you want to collect the most glass and have it the cleanest without it cross-contaminating. I don't know we'll solve the issue today, but those are the facts.
Even this Single Stream recycling facilities we visited.
First, I'm having a really hard time hearing. I don't know if anybody else in the room is, especially the podium. We're all having a hard time hearing you. Second of all, Michael, you're the moderator, right? You made a comment with regard to 3 through 7 bales. Can you repeat what you said? Because I thought I heard you say that it's all getting recycled.
No, I did. I said number 3 and number 7 is not getting recycled.
I'm sorry, guys. I can't hear.
I said number 3 and number 7 is not getting recycled.
Okay.
Okay, they're not. But the rest of that package is being targeted at the recycling facilities, and it's being bought in the system and going to recycling facilities for the recovery of polyethylene, polypropylene, and sometimes for polystyrene.
Because the MRFs that I've been into, it's like 40% of the 3 through 7 bales end up going to landfill.
That was the case when markets were down, but it's not the case recently. That's why the markets are so tight for new people to come in and get bales. I have something for Scott. Scott, when it comes to what AMP's plans are you taking the visual system that you have and using it the way other people are starting to use it when it comes to optical sorting combined in a process with robots and utilizing them sort of in tandem or multiple applications across the same line? Or are you just doing robots at this point?
We're just doing robots at this point. We are testing several different types of technology to see how we can continue to improve recovery from recyclables and the residue streams coming out of MRFs.
Okay. And we apologize for not having loud enough mics. We weren't aware of that up here. So thank you for telling us. Any other questions out there?
Thank you. So Scott, my question was for you too. On the surface, it looks like you're a hardware company, but I really think the gold in what you guys do is probably that data. That reporting data, with ERP, I think is coming, my personal opinion. Being able to calculate the recovery rates, greenhouse gas emissions, all those things. I see what you guys are doing, and it's kind of on the cutting edge of this industry, and I think it's totally going to disrupt it. Do you foresee, or do you already have MRFs where there are more robots than there are their human counterparts?
There are a couple MRFs that have equal amount of human counterparts, and I mean we've got up to 16, 17 robots in some facilities. We've got robots 1 up to 16, depending on the size of the facility and the size of our MRF. But with our data, to your point, and that's our software data as a service, you don't need a robot to be able to capture that data. We can install our vision system on, again, any line up to a certain width, and I'm actually working on figuring that out because I was asked at a meeting last week, what size belt, I want to put it on an accelerator belt, I want to know what my inbound material is before I start sorting it so they can know their yield on the back end. They can also know recipes in terms of production if they get more of, this plastic, polymer, color, or whatever, right? So we're working to that point. We're very positive and in the same space that the data is going to really drive how MRFs operate and how they can control price, education back to their suppliers, so those suppliers can then educate the consumers, right? When we all put trash and recycling in the bins here, right, it gets picked up. No one's educating really us. But if that comes back and it starts to be, data-driven and cost-driven as well, if you can start pinpointing where your issues are coming at the MRF, then the costs can be associated with the people who are creating the problems, not just spread across every single ton that comes in the door equitably to everybody, So we agree, and thank you for that. Yeah, we believe data is going to play a major role in understanding how to capture more recyclables and recoverables as we move forward. And we're really making a strong push to make that data valuable and accessible.
Great. Well, thanks. And this, the situational awareness of knowing how much material, almost like I see kind of a positive impact from a supply chain perspective, so that buyers could have real-time access to know how much material is coming, where it's coming from, and when they can expect that material. So I think you guys are doing some good stuff.
Thank you.
Thanks.
And that day is coming. Any other questions?
All the way back there.
One more out here.
I'm curious your opinion of, for instance, the Purple Can program in Fairfax County, Virginia. It's where they're collecting glass at transfer stations for cold-in-place recycling and the like, if that was something that you considered and if you had opinion.
I can't hear the question.
Can I paraphrase it? You wanted to know what Will thought about the Fairfax County recycling program, where they have a drop-off consolidation system, a glass cleaning system in Fairfax, and they feed from around that area.
We're seeing several programs taking glass out of the curbside program and putting it into drop-off systems around. The Ohio project that we funded was specifically that. The Orange County, North Carolina program had that, though it did have a restaurant collection that was operated by the city coming into, or the city of Chapel Hill into that program. But there are more and more, specifically James City County, which is not far from Fairfax, but between Williamsburg and Fairfax, just put containers, grant-funded containers that went out at all their convenience centers to haul to a bunker at the local glass bottle manufacturer plant, where they're not immediately consumed. It still goes to Western Pennsylvania to be processed, but it's going back on the same truck that are bringing them, call it, to go into the system. I expect we're going to see something that looks like that around feeding the Wilson, North Carolina beneficiation facility, and probably others down the line. OI has made a commitment to providing support for that collection where they have all of their plants across the country.
Any other questions? If not, I want to give you some time back, and our speakers will be up here for 5 minutes or so if you want to address us privately. And we thank you for your time, and thank you, gentlemen, for this presentation.